Well, hello Internet, and welcome to part 14 of my C# video tutorial. This one is going to be covering custom collections, indexers, enumerators, operator overloading, custom casting, anonymous types, and a whole bunch more. So a whole bunch of complicated topics all in one video. And like always, all the code and a transcript of the video is available in the description underneath the video. And I have a lot to do, so let's get into it. Okay, so here we are. What we're going to do is create a custom collection. So I'm just going to use something very, very simple here. I'm just going to come in to create an animal class, and I'm going to go string and name and create this property. And the getters and the setters. All right, so we have that all set up, and then I'm going to create a constructor, and that's going to be all we're going to do with this guy. So animal. And it's going to receive a string, and that's going to be the name, and we're going to say no name as a default. And then I'm going to set the name right here. All right, so pretty simple stuff. And make sure that's capitalized. And make sure that's capitalized. All right, so we have that all set up, and now we're going to jump over and create our custom collection. All right, so I called this guy animal form. And what I'm going to do here is I'm going to have this inherit Enumerable, which is going to provide for the option to iterate over our collection. So I'm going to go IEnumerable. And that's going to give me an error that's going to say that I need to fix things, but I'm going to do that on my own right here. Now this is going to hold a list of animals. So I am going to create a private list, generic animal list here. And I'm going to call it animal list. And we'll go new list, and animals is going to be stored inside of there, of course. And there we go. Got that all set up, and we're going to be using that. Now I'm going to create our constructor for this guy. So animal farm, once again, and it's going to receive a list of animals. And it's going to be animal list. Then I'm going to go this animal list is equal to the animal list that was passed inside of there. Okay, so we have that set up. All right, we'll keep moving on. I'm also going to create a constructor that doesn't receive anything. So we'll just go animal farm, and that's not going to get anything. We'll just leave that just the way that it is. And now what I'm going to do is create an indexer. And how we're going to use or create this is go animal. And then to create an indexer, you're going to use this followed with the brackets. And then I want to use integers as the indexes for this. And then I just need to define what's going to happen whenever we call for individual pieces of this collection. So it's going to return an animal, and that's going to be from the animal list and the index that is provided inside of it. So there we go. And of course we have to put curly brackets in front of this instead of the other thing we had right there. And close that off, and then put the curly brackets there at the end. Then I need to define what happens if I try to set a value. I go animal list once again, and I'm going to call insert and the index that I want to insert into, and then the value that I want to insert into, and that's it. Now that allows me to define exactly what's going to happen whenever the user wants to pull information from the collection or set information. Come back here, close that guy off. We can also come in here and set up count so that it works properly. How we do that is just go public int and count. And then we'll just define get for this because there is no set. And what it's going to do is just return animal list, and we can call count on it inside of here. All right, so there we are. So now we have the ability to pull information, add information, as well as receive the number of stored variables inside of it. Now this guy up here is complaining because we need to create another function down here, and we're going to call this enumerator, and we'll go IEnumerator, or enumerable, I mean, and get enumerator. And what this is going to do is return an enumerator that's going to be used to iterate through our collection. So we need to define how this is going to be set up. And it's quite simple. You just say return animal list, and then you call get enumerator. And you're going to do that every single time. Doesn't matter what you're working with. Okay, so we have all that set up, and the error message is gone. So we will save it. And now we'll go test it over in the program file. All right, so here we are, and I'm going to come down here and into main and just start doing some stuff. And like I said, indexers are just going to allow you to access items like an array, like a collection, like we've seen so many different collections. So what I want to do here is create an animal form object. So I'm going to go animal form, my animals is equal to new, and animal form, and create that guy. And then I'm going to add some animals to it. So we'll say my animals, and I'm going to say what index I want them to go into, and they're automatically going to go in there because we set it up with the getters and setters. So we're going to throw an animal inside of there, and its name's going to be Wilbur. Now let's throw a couple more inside here. Whoops, forgot to put the equal sign inside of there. Now we have that set up. Throw a couple more random animals inside of here. Change the indexes for this guy, so 2, and change that to 3. And we'll throw another one inside of here, Templeton, and we will put Gander, and one more. Why don't we put Charlotte? Completely random names, have no idea, there's no connection between them. All right, so now we can cycle through them just to show that this collection's working. So we'll go animal I in animal, or my animals, and then we can print this out. And I normally don't use shortcuts, but I'll show you this, and I guess every single time I do it, I'll just explain what I'm doing. If you want to go and get right line to show up on the screen, just go CW and tab, and it pops up there. All right? I know that sometimes confuses people because they're like, why did that pop up so quick? Well, that's what it is. All right? So there we go. And that's going to print out all of our animals. And why don't we save that and run it and see how it works. And there you can see, quite simply, it prints out Wilbur, Templeton, Gander, and Charlotte. All right? So cool stuff. Now what I want to do is create another class, and I'm going to show you how to do things like operator overloading and how to cast into different types and so forth and so on. So I'm going to create another class called box. Okay, so here we are inside of our box class, and I'm going to define a couple different properties. So we are going to have a double. It's going to store the length inside of here. So we'll go gets and sets. And then we're going to do the same thing. It's a three-dimensional box. So we're going to throw some more stuff inside of here. So box is also going to have a width, and it's also going to have breadth. Okay, so we have all those set up. Now, of course, we're going to have to create our constructor. So I'm going to go public box and handle the situation in which they don't enter anything into this. Down here, and we'll say this. And the defaults are going to be 1, 1, 1, 1, 1, and that's going to be passed to the main constructor. Now the main constructor is going to obviously be called box, and it's going to receive a double, and I'm just going to call this L, and it's also going to get another double I'll call W, and another W, or another double that I will call B for breadth. And then we'll just come in and go length is equal to L, and width is equal to W, and breadth is going to be equal to B. Okay, so we have those constructors all set up as well, and we'll keep going here. Now what I want to do is show you how you can overload operators. Now you're going to be able to override a whole bunch of different operators like plus and minus and multiplication and division and modulus, not equals to, not equal to, greater than, less than, greater than, or equal to, less than or equal to, and then the shortcut increment and decrement. Okay, so those are going to be the guys you can pause there, or like I said, the code's always available in the description. What I want to override or overload is the plus. So I'm going to define what happens if somebody tries to add two boxes together. Okay, it's going to return a box, and then you're going to put operator followed by the operator you want to overload. And this is going to receive one box, which is going to be box 1, and it's going to receive another box, make sure it's capitalized, whoops, capitalized, and that's going to be box 2. And then what you do is you just define what happens. So what we're going to have happen here is I'm going to say the length, well, first off, I want to create a new box. So I'm going to say box, new box is equal to new box. And then I'm going to define what happens with this new box based off of the two boxes passed in. Well, length is going to be equal to whatever box 1's length is, plus whatever box 2's length is. And go like that. And we're going to do exactly the same thing for our width and our breadth. So we'll go width and width and width and breadth. So breadth and breadth and breadth. Okay. Okay, we got all those set up here. I have to close off this box right there so I stop getting error messages. And at the end of this, I have to put a semicolon. Oop, might have an extra one in here, so let's get rid of that. I don't know how that happened. Put a semicolon right there. And whoops, put a semicolon there. I should have put a comma there instead. Got that fixed. And then get rid of that one altogether. My microphone was in the way there. That's the reason why I messed that up. And this is going to be tabbed in here. And then after we have all that set up, we're going to say return new box with all of the new settings that we defined inside of it. Close off that other curly bracket we have right there. And then what we're going to do is we're going to overload the abilities to subtract two boxes. Let's just copy all that and come down here and paste that in here, and we'll just change this plus to a negative, and then we'll change these pluses to negatives. So now we'll be able to add and subtract boxes quite easily. Now we're also going to, I'm going to show you how equality works, and then I'm sure you can figure out all of the other different things you can overload. Basically what we're going to do here, let's just paste this in here to save a little bit of time. The operator that we pasted in, I'm going to change this into equals, and then we can get rid of all this stuff right here. And instead, what I'm going to do is I'm going to say if, and we'll go box 1 length is equal to box 2 length. And then we're going to say and, because they have to all match up. We're going to do the same exact thing here. We're going to copy this right here. Oh, just copy that right there. And paste this inside of here. And then we'll go and once again, and then we will paste that inside of there. And we'll just change this to width, because we're going to say that the length, width, and breadth have to all be the same. And change this to breadth, and change this to breadth. So if all of those things right there are going to be equal, what we're going to do is return true, because these two boxes are equal. Otherwise, we're going to return false. And I need to come up here, and this is going to return a bool, not a box. So we'll change that to Boolean. And this is giving me an error saying that I need to do a matching not equals to. So no problem, I'll do that as well. Paste that in there, and we're going to say not equal to. And then what we'll do here is we'll say not equal to, and then we'll change these to or. Because if any of them are not going to match, then we'll have a problem. So we'll change this to or, and then we will change this to not equal. All right, so we have all of those set up. Now let's say we also want to define how your object is going to be converted into a string. Well, we can do that quite easily just by overriding the toString method. And you've seen this before. So we're just going to say, do it real quick, override. You can also convert into other different data types though, and I'm going to show you that next. So I'm going to say toString, and whenever this guy is going to be called, what it is going to do, whoops, gave me this silly thing. Let's just get rid of that altogether. What this is going to do is return, and then you can put anything you want inside of here. So I'm going to do a string format, and I'm going to say the string that's returned is going to say box with height, and then throw in whatever the height is inside of there, width, and throw in the width, and then throw in breadth, and whatever that's going to be. Come out of here, and then just go length, width, and breadth. And there you go. Now, whenever toString is called for this, or whenever we try to print this out as if it is a string, this is the message it's going to print out. You could also, however, and this is not going to make total sense, but I'm just going to do it and you'll know how to convert a different data type into an integer. Let's say you want to convert from a box into an int. So how you would do that is you would say public static explicit operator and int, and it's going to be receiving a box and trying to turn it into an integer. So you're going to have to define what that looks like. What I'm going to do is I'm going to say, I'm going to go int, and then I am going to, whoops, outside of that, I am going to then go b length plus b width plus b breadth, and then take those different guys and get the average and return that as an integer. All right, just to give you an example of something. But other situations, it's going to make sense how to turn an object into an integer, a double, or whatever. And to do that, you just change this to double or whatever else you wanted to turn it into. So it's going to receive a box and return an int. Let's do it the other way, where we are going to convert from an int into a box. To do that, you say public static implicit, once again, operator, And here you're going to say box. And what you're going to be receiving is an int, and you're going to convert it into a box. This might make a little bit more sense. In this situation, I'm going to return a new box object, and it's going to contain whatever the values are for the width, length, and breadth of the box. Okay? Now that we have all that set up, I'm going to jump over into the program file and test it all out. All right, so we're back where we were before. And let's say I want to test operator overloading first. I need to create a box 1, put a new box, and I'm going to say 2, 3, and 4. And I'm going to create another box object. And in this one, I'm going to change this to box 2, obviously. And then I'll change this to 5, 6, and 7. And then we can test what it looks like whenever we add these. If I want to create another box that is going to be made up of adding these two boxes together, I can go box 1 plus box 2, and there we go. And you're going to see what that looks like here, because I'm going to go, use the shortcut again. And here, I'm going to go box 3, and then I can use the toString here. So I can just say box 3 like this, and it's automatically going to convert it into some text. And we can run that just to see that that works. And yes, it does. See, box 3, box height, 7 width, 9 breadth. Okay, so it added those values together, and also toString worked to print that out properly. We're also going to be able to come in here and convert it into an int. So here, what I'm going to do is I'm going to say box int. So this is what the box looks like as an int. And then inside of here, I'm going to say that I want to cast it into an int, put box 3 inside of there like that. And then I'm also going to convert an int into a box. So I'm going to say box 4 is equal to, and I'm going to say that I want to cast into the box, and this is going to be a 4 integer is what I'm using. And if I want to go and output that, I can do it, of course. If I can hit the right button on the keyboard, I can say box 4. And then here, what I'm going to do is cast this integer into a box type. So I'm going to throw the 4 down inside of there like this, put that there, and then close that off. And we can save it and run it, and you can see that we converted the box into a 9 by taking these values, adding them up, dividing by 3, and you can see here that we generated the box from the integer type. Okay, so I got a little bit more time. Let's do another one. Another thing that is sometimes useful is sometimes you want to build a simple class that's just going to contain fields, and in some situations, what is called an anonymous type is going to be great for doing that. Just a simple situation. So let's say I wanted to say something like I wanted to define a toy here, equal to new, and we can give it, say that this is going to have a name, and it's going to be Shopkins, and it's also going to have a price, and we're going to say that that's $4.99. All right, there you go. Went and created that. Looks nice and neat. Now let's go and use it. So we will go like this, and then I'm just going to say, I want to pull in some information here, cost, and then this, and then this, and then close that off. And then to pull information from it, I can just say Shopkins, followed by name, and then Shopkins again, followed by the price. I'm going to do something a little bit more complicated. You're also going to be able to store these anonymous types inside of an array. So I'm going to create one. So I'm going to call this toy array equal to new, and throw the brackets inside of there like that. And then we're going to say new, and then we're going to define our names and prices. So we can say name is equal to yokai pack, and then I can do a price equal to $4.99. And then we're going to do the same thing. We'll go new and define another one. Whoops, like that. And name is going to be equal to Legos, and our price in this situation is going to be $9.99. And then come down here, throw a semicolon there. And we're going to be able to cycle through this also. So we'll be able to say for each, put var inside of there because we don't know what we're working with. And we'll say item, and then in toy array, and then to output the information, we can do so by just going like this, and then going costs, and then throw a $sign right there, and then 1, and then go and pull the information out. And how we pull that out is to go item Whoops, get rid of that extra one there. Item followed by the name, and then item followed by the price. And after we have that all set up, and I don't think we have any errors, let's run it and see what it looks like. Uh-oh, little error. What'd I do wrong? Ah, I see what I did. I should have put this in here. Just misclicked. Put that right there. I think this is still running. Yes, let's kill that. Oh, okay. And we'll throw this right here and throw our comma inside of there like that. And now everything looks peachy keen. Let's run it again. And there you can see that it went and printed out the first anonymous type information, and then it also cycled through the array with anonymous types. Okay, so there is a whole bunch of new information. We're getting near the end of the core of the C# language, and I think I'm going to be covering LINQ in a lot of detail in the next part of the video. And just like always, please leave your questions and comments below. Otherwise, till next time.